Welcome to Lesson 3 in Course 1, Portfolio Theory. In Session 3.1, you will learn the essential concepts of diversification and its benefits regarding portfolio risk. The learning goals for Session 3.1 are: you should be able to explain diversification benefits of firm-specific risks. You know how to build a portfolio of two risky assets. And students should be able to compute the minimum variance portfolio. The investment decision. The investment decision can be viewed as a top-down process. First, capital allocation between the risk portfolio and the risk-free asset, as learned in the previous session. The process of capital allocation determines the investor's exposure to risk. Second, asset allocation. With the risky portfolio across broad asset classes, for example US stocks, international stocks, and long-term bonds. And third, security selection of individual assets within each asset class, shares of UBS or Credit Suisse or Goldman or other stocks. Portfolio risk and the number of stocks in the portfolio. Consider a naive diversification strategy in which you include additional securities in your portfolio. For example, place half of your funds in ExxonMobil and half in digital. When oil prices fall, it is hurting ExxonMobil, but computer prices might rise, helping digital. As a consequence, the two effects are offsetting each other and stabilize portfolio returns. If we diversify into many more securities, we continue to spread out our exposure to firm-specific factors, and portfolio volatility should continue to fall as shown in panel A, when N is increasing. In panel B, portfolio standard deviation falls as the number of securities increases, but it cannot be reduced to zero. The risk that remains, even after extensive diversification, is called market risk. Diversification and portfolio risk. As previously discussed and highlighted on the two graphs, we need to differentiate between market risk and firm-specific risk. The risk that remains even after extensive diversification is called market risk. Risk that is attributable to market-wide risk resources, such risk is called systematic risk or non-diversifiable risk. In contrast, the risk that can be eliminated by diversification is called unique risk or firm-specific risk, non-systematic risk, or diversifiable risk. Portfolio diversification. In the graph below, the effects of portfolio diversification are shown using data on stocks of the New York Stock Exchange. The figure shows the average standard deviation of equally weighted portfolios constructed by selecting stocks random as a function of the number of stocks in the portfolio. On average, portfolio risk does fall with diversification from 49.2% with one stock to 19.2% with 1,000 stocks. 50% of risk reduction compared to a single stock can be achieved with a portfolio of 6 stocks. As a rule of thumb, a portfolio of 15 stocks is well diversified. Portfolios of two risky assets, an example of a 50-50 split. It is now time to study efficient diversification, whereby we construct risky portfolios to provide the lowest possible risk for any given level of expected return. So we consider two mutual funds, a bond portfolio specializing in long-term debt securities, denoted D, and a stock fund that specializes in equity securities, denoted E. The expected return on the portfolio is a weighted average of expected returns on the component securities with portfolio proportions as weights. As shown in this example, it results in an expected return of 10.5%. The variance of the portfolio, unlike the expected return, is not a weighted average of the individual asset variances. The variance of the portfolio is a weighted sum of the covariances, and each weight is the product of the portfolio proportion of the pair of assets in the covariance terms. In this example, the variance is 172 and the standard deviation is computed simply by taking the square roots, resulting in 13.23%. Portfolios of two risky assets. We have learned that the portfolio risk of two assets is defined as shown in the formula below by the weights of stocks and bonds, its standard deviation, and the covariance. This equation reveals that portfolio variance is reduced if the covariance term is negative. But even if the covariance term is positive, the portfolio standard deviation is still less than the weighted average of the individual security standard deviation unless the two securities are perfectly positively correlated. Portfolios of two risky assets focusing on covariance. Notice that the covariance can be computed from the correlation coefficient as shown in the formula below. All other things equal, we can say that if the correlation of debt and equity is increasing, the covariance of debt and equity will also increase. If the correlation of debt and equity is decreasing, the covariance of debt and equity will also decrease. Portfolios of two risky assets focusing on correlation. Replacing the covariance with correlation in the previously shown portfolio variance would result in the following formula. If the correlation is equal to 1, the formula can be reduced to the following term. If you take the square root out of this term, you would result to a standard deviation of the portfolio which is equal the weight of equity times the standard deviation of equity plus the weight of debt times the standard deviation of debt. If the correlation is -1, it is a perfectly hedged position resulting in the portfolio variance of 0. The formula can be reduced as shown in the formula below. If you substitute the weight of debt and solve for the weight of equity, you will get to the following term. Portfolio expected returns. We can experiment with different portfolio proportions to observe the effect on portfolio expected returns and variance. When the proportion invested in debt varies from 1 to 0, the proportion in equity varies from 0 to 1. The portfolio expected return goes from 8%, the expected return of bonds, to 13%, the expected rate of return on stocks. If the weight of debt is larger than 1 and the weight of equity is smaller than 0, the expected portfolio returns fall. This extreme position is financed in part by short selling stocks equal in value to the portfolio's net worth. If the weight of debt is smaller than 0 and the weight of equity is larger than 1, this strategy calls for selling the bond, fund short, and using the proceeds to finance additional purchases of the equity fund. Portfolio standard deviation. The graph below shows the relationship between standard deviation and portfolio weight. Look first at the solid curve for a correlation of debt equity equal to 0.3. The graph shows that as the portfolio weight in the equity fund increased from 0 to 1, portfolio standard deviation first falls with initial diversification from bonds into stocks, but then rises again as the portfolio becomes heavily concentrated into stocks and again is undiversified. The goal is to find the minimum variance portfolio for each curve. Note that with a correlation of debt equity of 1, no minimum variance portfolio can be computed, given the linear function and as there are no diversification benefits. The minimum variance portfolio for a perfect hedge with a correlation of -1 is at a weight of stocks at 0.375, resulting in a portfolio with 0 standard deviation. Portfolio expected return as a function of standard deviation. Now we can combine the findings of the previous slide to demonstrate the relationship between now the portfolio risk standard deviation, which is new, and the expected return. This is done in the graph below. The solid blue-colored curve shows the portfolio opportunity set for a correlation of 0.3. We call it the portfolio opportunity set because it shows all combinations of portfolio expected returns and standard deviations that can be constructed from the two available assets. The solid black line shows that there is no benefit from diversification when the correlation between the two is perfectly positive. Finally, for a correlation of -1, the portfolio opportunity set is linear, but now it offers a perfect hedging opportunity and the maximum advantage from diversification. The minimum variance portfolio. To summarize, although the expected return of any portfolio is simply the weighted average of the asset expected returns, this is not true of the standard deviation. Potential benefits from diversification arise when correlation is less than perfectly positive. The lower the correlation, the greater the potential benefit from diversification. The extreme case of perfect negative correlation is when we have a perfect hedging opportunity and we can construct a zero variance portfolio. We are at the end of session 3.1. After having carefully studied the slides and the relevant chapters in the book, please start with the review questions.